You can add numbers, but can you add invisible arrows? What if I told you that adding these arrows is crucial for AI to understand the world? You use vectors every day, even if you don't realize it. Think about it, when you throw a ball, you're using a vector to predict where it will land. Let's dive into the world of vector addition and see how it works. Imagine you're on a boat, and the wind is pushing you one way, while the current is pushing you another way. You can think of the wind and the current as two invisible arrows. To figure out where you'll end up, you need to add these arrows together. This is similar to how vectors work in math. You can add vectors by combining their directions and magnitudes. It's like combining the forces of the wind and the current to predict where your boat will go. So, how do you add vectors? Let's break it down step by step. First, you need to find the magnitude of each vector. The magnitude is like the length of the arrow. Then, you need to find the direction of each vector. The direction is like the way the arrow is pointing. Once you have the magnitude and direction, you can add the vectors by combining their components. It's like adding the x and y coordinates of 2 points. Let's see an example of vector addition in action. Imagine you're playing a game where you need to move a character from one point to another. You can use vectors to represent the character's movement. For example, if the character moves 3 steps to the right and 4 steps up, you can represent this as a vector with a magnitude of 5 and a direction of 53 degrees. If the character then moves 2 steps to the left and 1 step down, you can add this new vector to the previous one to find the final position. So, why is vector addition important? It's used in many real-world applications, such as physics, engineering, and computer science. For example, in physics, vectors are used to describe the motion of objects. In engineering, vectors are used to design and optimize systems. In computer science, vectors are used in machine learning and AI to represent complex data and make predictions. So, what did you learn today? You learned that vectors are like invisible arrows that can be added together. You learned how to add vectors by combining their components. And you learned why vector addition is important in many real-world applications. Here are the key points. Asterisk vectors have magnitude and direction. Asterisk vectors can be added by combining their components. Asterisk vector addition is used in many real-world applications. Next time, you'll learn about scalar multiplication and how it's used in AI. You'll see how to multiply vectors by numbers and why it's important for machine learning. Don't forget to subscribe and hit the notification bell to stay updated. See you in the next video.